your impossible homework assignment. And I said, this one's probably going to take, promise, 70 or 80 hours. All right, so how many of you have ever played the game tic-tac-toe? Played this game? You got the 2 vertical lines, 2 horizontal lines, and somebody goes first. So, you know, I maybe put an X in the middle, put an O, put an X there. Oh man, this guy's good. That was a tie. Game over, draw. We're all familiar with that game? You're trying to get either 3 X's or 3 O's in a row, either horizontally, vertically, or diagonally. Okay, so what we're going to do is we're going to create our own tic-tac-toe game. It's going to be a 2-player game, so you know your computer doesn't have to make moves for it. You know, you don't have to have an artificial intelligence for making moves. You get to choose all the moves. Now, if we are doing this, let's give you a starting point here. Just dump all this. Here, just in case there's some of this that's useful, I'll go ahead and throw that current code up in here in Slack. Before I delete it. Oh. Okay. So, we're going to represent our board as a list of lists. Okay? So if we think about this, what does a tic-tac-toe board look like? Well, you're going to have 3 entries per line, and you're going to have, well, 3 columns per row, and you're going to have 3 rows. So we want to represent each of our rows as a list, and then the 3 rows will live in a list itself. Okay, so we're going to have a list which is going to be equal to three lists. And each of those lists maybe starts off with underscore, underscore. We're dancing up here, promise. Just watching videos back there. You missed my dance. His phone is locked up. I can't get it to turn off. Android or iPhone? All right. So maybe what we do is we have our lists containing maybe initially underscores in our places, like that. So we have a list containing 3 lists where each list has 3 underscores in it as placeholders. Okay? Where as we start filling this in, maybe this is an X, this is an O, stuff like that. Okay? So let's go ahead and we're going to come out here and we're going to create our board. And the board is going to be a list containing some lists. This is going to be underscore, underscore, underscore. All right, so that's how we're going to represent our board. Okay, so now let's display our board. So we're going to write a function, so def display board. And we'll go ahead and pass this guy the board that he's going to display. And what we want him to do is we want him to go through every element of the list. And for each of those elements, display the contents of that guy. All right, because if we just say print board like this, and we come down here and actually I'm going to put the board down here at the bottom. And I go ahead and say display board, and I pass it my board. It's going to look like that. Where I really don't want it to look like that. I want it to actually look like a board. So one thing I can do is I can say for row in board, so we know that a board is actually a list of rows, right? That's how we're referring to them. I could say print row. Let's see how that guy looks different. So now it looks a little bit closer, but still a little bit funky maybe, right? So now we want to deal with each of those individual rows and print them out. So this is going to get us a row. Now we want to go through every column in that row. So for col in row, we're going to do something. And what are we going to do? We're going to say print col. And then what I'm going to do is I'm going to say, I don't know if you remember this from the book, but there's this thing that says end equals. All right, and then once that one's done, I'm just going to do print like that, and that'll kick it down a line, or if you want, you can do a \n in there if you want to kick it down 2 lines. All right, so let's look at what this guy looks like now. All right, so now it went ahead and it's not just showing me the default list look. Instead, I'm going through, I'm grabbing each column in that row, and I'm printing out the column, which is right now it's an underscore, followed by a space. Now, I can do a \T for a tab if I want to. That'll equal space it. So maybe that looks a little bit more like a board, something like that. Okay. Now, you also might decide that if you want your board to look a little bit more legit, maybe you have longer things like that, but let's just leave it like this. All right. So, for example, if we want to have our board, we'll just give ourselves some sample values in here and see how it looks. So looks kind of like a tic-tac-toe board. Okay. So that's our board and our display. All right. So now we're going to create a function called playGame. And playGame is going to take that board as a parameter. And we're going to have a couple of players. Okay, we're going to have a player 1 and a player 2. And they're going to alternate between who gets their turn, right? So we need to have a mechanism. So we want to keep looping until somebody wins, right? Now, we don't know how long that's going to happen for. So right now, I'm just going to say while true. So I'm going to create an infinite loop. You're going to want to change that true to be something that has to do with has somebody won. While there has not been a winner, keep going. Okay? So while true, we want to have some logic that allows us to ask the users for information. Okay? So I'm going to create another function here. Def prompt player. And this will be the player's name. And then let's actually call this, we'll call this make move. This is going to take the name and the board, and it's going to read something in from the player and attempt to make that move. Okay, so we really need the player to give us two pieces of information. We need them to give us a row and a column. Where do they want to place their move? All right, because we're going to have a player. So maybe we, instead of name, maybe we call this move val. So this will be either an X or an O, something like that. So we're going to ask the user two questions. Print move val, what row? Something like that. Okay. And if you want it to be on the same line, if you remember this from before, you can say end is equal to just a space like that. And that won't kick it down on a line. Otherwise, it'll be asking for your input of the next line. And then we're going to say row is equal to input. Because input's our tool for reading something in from the user, right? Okay. Now they're going to be giving us a number. So we can go ahead and say, give me the integer version of that number. Then we're going to prompt them again. We're going to say, what column? And we'll read that into a column. Now, just to prove that this is working, we're going to say, print, you want to move to row, and call. Just proving that we successfully entered it in. Okay? So let's test that here real quick. We're going to go ahead and we're going to just say test make move. And we'll go ahead and we're going to pass in this is for player X, and we'll pass them the board. Run this guy. Repro. Expected indentation block. Oh, it didn't like that I didn't finish my play game yet. I'll just take it out of there for a second. All right, so it's asking X what row. So we'll say I want to go to row 1. So maybe we'd assume this is 0, this is 0, this is 1, this is 2, this is column 0, 1, 2. So this will be, we'll say row 1. What column? Column 2. All right, so it's type must be a string. Oh, because we're concatenating on ints. Just to display it for right now. We'll just convert it back to a string, proving we read it incorrectly. Yeah. All right, so we'll say 1, 2. So you want to move to row 1 and column 2. So we're reading in those pieces of information correctly. Okay? Now, when we say row 1, column 2, and we put our move value there, we want to update board with that, correct? So we can say something like board at position. So board is going to hold a bunch of rows. So board at position row. And then within that row at position col is going to equal move val. So that'll make our move. And then we'll display the board again. All right, so we're going to put this at 1, 1, and that put it at the center, right? Now we need to be able to go back and forth between our players, okay? Now, making our move there, we have a primitive version of making a move, but they can't just move anywhere, right? They have to give us a move that is a legal row and column. They also have to give us a move in a place that doesn't have an X or an O in it. We can't overwrite a person's X with an O just because we think that would be a better move for us, right? So right now we're just forcing the value there. We're not actually making sure we're allowed to make that move. All right, so we'll go ahead and display the initial board. So I'll go ahead and do that. Def play game. This guy will take in the board as a parameter. I'll say while true. We'll go ahead and display the board. Then we'll ask for the move on X. Then we will display the board again. Well, actually, I want to put some logic in here. There's an easier way we can do this, but I do want to give us some logic for flipping back and forth between X and O. So I'm going to create a variable here called moves. And moves is going to equal X and O, are two different kinds of moves. Then I'm going to have another variable called ClearPlayer, and we're going to say 0. So when we make our move, we're going to be making move on moves at position ClearPlayer. Okay, so the first time through, that's going to be the X. Moves at bucket 0 is an X. The next time through, I want it to be a 1. Then I want it to be a 0. Then I want it to be a 1. Then I want it to be a 0. So how do I take ClearPlayer and make sure that it always alternates between 0 and 1? Well, the simple solution, which is the one we're not going to necessarily use because it's not the cool kid solution, is just ask a question, right? If it's currently a 0, make it a 1. Else make it a 0. So you can ask the question, if ClearPlayer is equal to 0, set ClearPlayer to 1, else ClearPlayer equals 2. And that's fine, right? That'll, I'm sorry. Set it to, if it's equal to 0, set it to 1, otherwise set it to a 0. So that'll toggle it back and forth. So we'll display the board, ask player X to go, switch to player O, display the board again, ask player O to go, switch to player X, so on and so forth. So I should be able to say play game, passing it the board here. So it's asking X what they want to do. We'll go to 1, 1. Okay, so it's showing that. Now it's asking O what they want to do. So we'll go ahead and we'll do 0, 0. Okay, now they're asking X what do they want to do. Well, we'll go to 0, 0 as well. We like that move better. Okay, now it's O's turn. And O is going to go to 2, 2. And then X is going to say, yeah, I like that one too. So now I won. So we don't have any oversight with whether our moves are legal or not at this point. So you're definitely going to have to add in some oversight to make sure that they're allowed to make the move they're trying to move. We are already toggling back and forth. You're going to have a function for whether or not there's a winner. So def is winner, passing it the board. And this guy should return true if there is a winner and false otherwise. Right now, I'm just going to have him return false always. So it's not going to think anybody's ever won. Okay, so then in here, what I can say is while not is winner, or if you want to write it differently, you can say while is winner is equal to false, if you like that version of it better. Okay, so as long as we do not have a winner, keep looping. What we're going to do, we're going to show the current board, ask the current user how they want to move. We'll read in their move, we'll make their move. So in our code here, we need to ensure the move is legal or ask them again. Make sense? So that's something that you're going to need to do before you just randomly let them make the move. Okay, and you're going to keep playing over and over and over again until game is over. Okay, when the game is over, we're going to ask them. So as soon as we exit out of this while loop, we want to ask if they want to play again. If yes, clear the board and start over. That make sense? So then we're going to have a function here probably called ClearBoard. That'll take the board as a parameter. This function should perform the logic to clear the board. Now, we'll go ahead and write this. So to clear the board, we have to do what? Loop through every row, loop through every column, and put an underscore there, right? So for row in board, for call in board at row. Actually, this isn't going to work the way we're doing this here, because this is going to give us the character that lives there. Really what we need is we need for I, let's see, let's call this row num. For row num in range of 0 to length of board. That's the number of rows in board. And then for call num in range of 0 to length of board at bucket row num. And then we'll say board at position row num call num is equal to an underscore. Like that. Okay. If we want to test that real quick, we can go ahead and we can throw some X's and O's in our original board. And then we'll go ahead and say clear board, passing it board. And that should revert it back to all underscores if this works. Is winner equals false. Oh, is winner requires me to, we wrote is winner up here, but it takes a board as a parameter. So we have to pass the guy the current state of the board. All right, so that board looks reset to me. It looks cleared. All right, so clear board does what it's supposed to do. I'll go ahead and put this guy back to his original state. Okay, so for your homework, we're going to implement, here, let's just put it in, now I've given you a lot of code here. It's a starting point. So this should not be a 25-hour thing here, promise. This should be a minimum of 50. No, this should be a lot less. I've given you a pretty hefty starting point here. All right. So we'll go to content. This is homework number 5. Implement tic-tac-toe given the starting point on Slack. So I'll put this code up on Slack for you to get the starting point. Your game should ensure that each user makes a legal move. Ensure that each user makes a legal move. Your game should print out who wins when there is a winner, or that it is a tie if there are no more legal moves. After a game ends, your program should ask if they want to play again. If yes, clear the board and start again. Make sense? So you're going to finish implementing tic-tac-toe given the starting point I've given you. Okay, and this is due tomorrow by midnight. That's impossible. We should all pool our resources. We can have this done by 10:10. So everybody empty their pockets. Then we wouldn't have the learning experience. And the last thing I'll say here is make sure that you are providing me the self-evaluation. Over here, you have this self-assessment thing. Gives you this little template. So when you turn in your homework, copy this guy and paste it in with your homework so that you can tell me about the 25 hours you spent, where you struggled. That way I can give you partial credit for a solution that looks like garbage. Does that make sense? This is your opportunity to tell me, okay? And I've asked for this before because several of you have been giving this to me. But over half of you have been omitting this on your assignments. Okay, go ahead.
I just thought it was just for the first assignment, not as an assignment.
All right, yeah, so every assignment. Do it for every assignment because that's your opportunity to plead with me to give you a better grade than you deserve based on what you've submitted, right? Because your experience, for instance, I suspect that the 25 hours he spent on his homework is probably way more valuable than what his final solution was. So if I hear about that experience, I hear about the effort he put into that, that's going to make me, take pity on him, right? And it's not just 25 hours. I want to know about your experience, where you ran into problems. Because I might be able to look at your code and see, if he had just gotten over this one problem here, the rest of it would have been no big deal. But because you hit that wall, and you told me you hit that wall, and you just banged your head on it for a while and couldn't solve it, you got stuck. All right, so I need to know about your experience. So copy this into your solution to the code. That make sense? All right, so let me take the code here, and I will paste it into Slack. And did I hear you ask, what is Slack? Did I hear you ask before, what is Slack? I definitely heard you ask it. I'm just wondering whether or not you've been using Slack? No, you haven't been using Slack. I get it. You had a first homework assignment to use Slack. Didn't you have to post your stuff for your first assignment on Slack?
That wasn't good, but yes.
So you didn't do that?
It wasn't it was an email.
He found an excuse for you. Here. Go to This is for you. Go to cuwcs.slack.com, create an account, and join the 535 group. All right, questions, comments, concerns, bribes. You got a bribe? Sure.
How do you get the variable rows and columns? How did you define it?
Where are we talking about up here?
Yeah.
I just made them up. This could have been LOL and heh. Okay? Because board is a collection of, if we look at board down here, this guy is a collection. Here's the first element in there. That's one row. Here's the next element in there. That's another row. Here's the next element in there. That's another row. So when I say 4 rows in board, the first time through, row will be equal to that guy. The second time through, row will be equal to that guy. The third time through, row will be equal to that guy. Then when I say column, for cols in a particular row, the first time through, col will be equal to that guy. The second time through, col will be equal to that guy. Third time through, col will be equal to that guy. Does that make sense? So it goes through each element of a list. So instead of saying go through the range, where this is bucket 0, this is bucket 1, this is bucket 2, this is saying go through every element that's in this list. The first time through, the element I'm looking at is that one. The second time through, the element will be this one. The third time through, the element will be that one.
And then the next volume is going to go through the element inside of each of those rows.
Well, this is for displaying it. So when I display it, for each row that's in there, I want to go through all the columns in that row. And what am I going to do for each column in that row? I'm going to print out the column followed by a tab. So what that's going to do is it's going to give me, I printed out the column, and then I printed out a tab that takes me to there, leaving me at the next thing. So the next time through the loop, I print out the next column followed by a tab. Then the next time through the loop, I print out the next column followed by a tab. That's the end of this for loop. Then this print statement happens next, where I kick it down a line. That's what gets me down to this line. So now I'm on my next row. So for that row, for each column, print out this guy, then this guy, then this guy, kick it down. Now I'm on my next row. This guy, then this guy, then this guy. Make sense what it's doing? Okay. Other questions? Comments? Concerns? Still bribes. We're over. Bribes are closed, I guess.
So you want to.
Go ahead.
We want to define the list of these. So it's just going to be the bracket. It's like next to the bracket.
A list is square brackets.
Yeah.
Well, what is it that you want to define?
A new list of things.
Um,
I just want to get.
oh, yeah, it would be just like this. This is a list of lists. That's what that is. That's a list of lists. I just happen to go ahead and fill in each list with underscores right now. Okay. But here, I'll give you a quick hint for checking to see if there's a winner. All right. What you want to do is you want to go through and check, because there's 8 ways to win, right? You can win on the first horizontal, second horizontal, third horizontal, first vertical, second vertical, third vertical, or the 2 diagonals, right? You have a winner there if in any one of those they are all the same value, but they're not equal to underscores. Be careful about that. Otherwise, you might detect that there's a winner right off the bat, because everything is an underscore, right? It's like, win. All right. So you want, basically, I would say check all 8 of those possibilities, right? If the first horizontal is either all X's or all O's, that's a winner. The second horizontal, all X's, all O's, that's a winner. So on and so forth. If any of those 8 scenarios are true, you have a winner. Otherwise, we should keep playing. That make sense? But the real hint there is, as you're checking, don't get fooled that an underscore is a match. Because you might have a horizontal with 3 underscores in it, and you might think that's a winner, and that's not, right? There hasn't been any moves there. All right, anything else? All right, see everybody next Wednesday.